In this video I will try different sound cards with this Softrock. This unit is in the original shape, I haven't modified it in any way. I'm using a 8657A signal generator, supposed to be a low noise generator, and I have set it to minus 18 dBm and connected it directly to the Softrock. And this is what I see on the spectrum. I have set the S meter. Well, I have to click on the signal first to show minus 18, and I can read it out like that. Minus 18 dBm, in full agreement with the signal generator. Look at the signal here, while I am increasing in steps of 0.2 dB. 1, 2, 3, 4, 5. And you can see at this point it has become much stronger. So a reasonable upper limit, maybe 17.8, but I take 18 dB as the reference where it saturates. And this level will of course be independent of the sound card, because saturation is not in the sound card, it is in the Softrock. And I have to check it, of course, for every sound card. I do that by looking at the margin. Press A, and here you can see the amplitude margin. It's about 4 dB. So we are 4 dB from saturation. When the delta 44, which is in use now, is set in consumer. And that's the optimum setting for this Softrock. And I'm using it the standard way, just a plug that fits in the box and into the breakout box of the delta 44. I switch off the signal in order to look at the noise floor. And then we see on the spectrum here, it doesn't really look very nice. And you can see also in the waterfall here. This is a standard problem. I fixed it this way. And you can see here, this is gone. And then I look at the noise floor. You can read it out like this. Minus 124.3 dBm. Once more. Minus 124.3. I have set the bandwidth to accurately 1 kilohertz. You can see that. I grab the BFO with the mouse and go up here. Well, I center the frequency to this frequency first, and then I grab the BFO and look at this frequency. It is very close to the 3 dB point, as you can see where the mouse is and where the BFO line is. And on the other side here, it's on the next kilohertz. So the bandwidth is 1 kilohertz, and 124 and in 1 kilohertz, that means 154. So that is 20 dB below room temperature, which is at 174, and 0.3 dB better than that. Now, the precision of this signal generator is promised to be plus minus 1 dB. And I think it is a little bit better than that. at this low frequency. Next thing to look at is what happens if we unplug the cable to the breakout box, like that, looking at the noise from the sound card only. Well, I can clear the graph like that, and you see the difference is small. But I can read it out, hopefully. No. Something is wrong, that this readout doesn't always work. Now the level is minus 125.5, well, 125.6. So most of the noise comes from the sound card, and a small fraction of the noise comes from the Softrock. The spectrum from the signal generator does not look particularly nice. I switch it on and you can see this, and also the noise floor is raised here, as you can see from the green in the waterfall. And at close range there is a lot of unpleasant stuff. The data book tells me that this is how the sideband noise typically looks, but that is 500 megahertz. The table here tells me typical in the HF range should be minus 130 dBc per hertz. So I will check that. I'm now 20 kilohertz above the signal, and I can read here the level is minus 117, and since the carrier is at minus 18, we have 99 dB, and the bandwidth is 1 kilohertz, so this means minus 129. They say typical 130, but promise 124. So this fits. And this is quite normal for an amateur station. Rigs are not much better than that. I have now connected a good signal generator. It's a crystal oscillator. The level is the same, but you can see it doesn't give much noise, and it doesn't have the sideband noise close to the signal. And you can see here also in the waterfall. So the Softrock is pretty good. And I can look 20 kilohertz away. Was it somewhere here? And this is the noise floor. And if I switch off that generator, you can see the difference is very small. We can see it in the waterfall. There is some reciprocal mixing, but not very much. For the study I'm doing, this sideband noise doesn't matter at all, because I look at the signal at the center of the signal to set the gain, I mean the calibration of the S meter here, and then the noise floor, I measure that when the signal generator is switched off. So that's the way I can compare the clipping level and the noise floor with different sound cards on the Softrock. Here is a USB sound card. It's this one, and they say, if you look here, no drivers required for Windows XP 2000 Vista and 7. So this is XP and no drivers should be required. When looking inside, I find a VIA 1630A. Here is what VIA technology has to tell about it. Embedded audio codec, 90 dB, 16 or 24 bit, and it goes up to 192 kilohertz. I found this drive routine on the internet. So I ran this installer to get some control on this USB sound card. ASIO does not work, so I select microphone input from WDMKS, that is number 72. At 96 kilohertz and 32 bits. And 2, that is INQ for a single RF channel, and no time shift between the samples. And I make latency factor 1. And the Softrock uses the SI570, so that's number 3. And for output, no port audio, and number 4, that's the motherboard sound card. The noise level is fairly high, and if I increase 1 dB like that, we can see that saturation is below minus 27 dBm. I have to go to minus 28 to get a clean spectrum. But since I installed the drive routine from VIA, I can use the volume control from there, like this, and then audio and volume, and make it minimum, like this. And now I can increase the signal level like this, maybe like this. That is minus 20 dBm. So the gain is lower now than it was by default, and that it was when I didn't have the VIA driver installed, because this gain control was not available before I installed that drive routine. Then the clicking on the volume control here would say you cannot do this because there is no volume control, or something similar. Anyway, this is the best we can do with this particular sound card with the driver. Maybe there is another driver around that could reconfigure the input to be a line input. That would be more appropriate for our purpose. Anyway, I go here and I set the gain. Seems I already did that. It shows now 19.9, while the true value is minus 20. That is accurate enough, so I switch off the signal generator to look at the noise floor. And the noise floor is minus 121 dBm. That is about 3 dB above the noise floor when using the Delta 44, but I have not yet used this capacitor trick, so I put the capacitor here. And seems it doesn't make much difference, or seems it does not make any difference at all. Well, a small difference. With the capacitor I see minus 121.5. Here is another low-cost USB sound card. It comes up as number 71 here in Port Audio. So I select that, and it can give me 96 kilohertz and 4 bytes. So I say 96 kilohertz and 32 bit. And of course 2, that means I and Q for a single RF channel, and 0 because I don't think there is any error in the time shift between the samples. And latency factor, I just make it 1. I hope this computer is fast enough to not need any extra margin. And the hardware is the Softrock, that is the SI570, means number 3 here. And output B without port audio, and I select number 4, that's the audio of the motherboard on this computer. X and W to save. By default, gain is very high. I go up 1 dB in the signal level and it saturates. And this is at a level of minus 44 dBm. I open the audio control things here and go for audio. I get rid of that. And then volume. And I get some volume controls. Speaker, no. Volume. I wanted the input. It's here. And I turn it down to minimum. Well, then I get nothing. So this is a little bit more difficult. I know that the Softrock saturates at minus 18, so I set the amplitude to minus 18 dBm. That's the level where I want the sound card to saturate. And then I adjust the volume. And that's not possible. This is minimum and there is no signal, and I go up just a single pixel, and then there is saturation. So I have to turn down the signal level here, minus 21 dBm. That's the point of saturation when I set the lowest possible gain of this sound card. And the next thing is to switch off the signal generator and look at the noise floor. And it's here. And I have to find out what is the noise floor. Minus 118.8. Well, I don't have the capacitor here, so I have to put it in place. I mean, this capacitor is an obvious modification that should be done inside the box. But I'm using the standard box now. And with the capacitor, the noise floor I see is minus 118.9. This is not very good. Saturation as minus 21. That is 3 dB earlier than the Softrock itself. And a noise floor of minus 119, rounded. That is about 5 dB worse than what we get with the Delta 44. There are other cheap sound cards that do better than this one. Here is another low-cost device. It presents itself as a microphone USB with 8 kHz sampling rate as the only alternative. Now, this thing comes with an installation CD, so I will install the drivers for it. So it comes up like this, and I click Install Driver. After a reboot, I find that the microphone input from the USB audio device presents itself as a device capable of 8 kHz only. I don't know the details of Microsoft Windows, but I can see that the MME driver for the USB is 8 kHz to 192 kHz. So I open it as number 1. This is what I see. Microsoft kindly upsampled from 8 kHz to 96 kHz. But that's not what I want. This sound card is totally useless for SDR purposes, as far as I can understand.